Detectives are great at tracing clues. And guess what? Developers need that skill too. Hi, I'm Sham, an Android developer. In this series, I share problem-solving techniques for different coding challenges. Let's get into it. So, what is sliding window technique? It's an algorithmic approach. You define a window, a subset of your data, and slide it across your input. At each step, you check or calculate something based on that window. Think of it like dragging a real window across a spreadsheet, row by row, column by column, observing what's inside at each step. And our problem today is how to find largest contiguous subarray of different window sizes. My first attempt worked, but it wasn't the most efficient solution, especially for large data and time complexity. Here's why. I checked each possible maximum subarray, which is called brute force approach, stuck in loops, and the greater the window size, the more complex it gets. And here is where sliding window came in. You simply begins with window as a subset of the array. Add its elements together, then you slide it. Add the next element in the slide and subtract the one you are sliding past. Just like that, no need to recalculate everything from scratch. Now it's code time, and you could find this code snipped in a comment below. Let's walk through this Java code using the sliding window technique. We start with the run method that takes k, the size of the subarray window we want to examine. We define our array, get its length, and prepare a variable temp to store our current window sum. First, before doing anything, we check if the array is long enough to hold the subarray of size k. If not, we print an error message. Second, we calculate the sum of the first k elements. This is our initial window. Third, we assign this initial window sum to a variable called sum, which will keep track of the maximum sum we find. Fourth, and here comes the sliding, in each iteration we add the next element entering the window and subtract the element that's sliding out. This efficiently moves our window forward without recalculating everything from scratch. Fifth, if the new window sum is larger than our previous max, we update it. Finally, we print the largest sum we found across all sliding windows of size k. So when you hit run, you could find that the largest subarray of size 3 is 40. That's how the sliding window approach optimizes subarray sum problems. Now it's your turn. Can you use sliding window to find the average of all contiguous subarrays of size k? Give it a try and share your thoughts and answers in the comments below. And remember, it's just a trial and error. You don't have to know it all at first time. It's just a cup of coffee, your problem, a pen and paper, and that's how problems get solved. See you in the next problem.